Hello and welcome to this video on the diagnostic test calculations. These are the questions and the calculations that usually come up in your exams. This video is a part of our series on epidemiology and biostats. My name is Dr. Wahab Fazil. Let's get into it. So let's start talking about something I call the 3x3 table. You must have heard of the 2x2 table. In my previous video, I talked about the 3x2 table in which we had 3 columns and 2 rows. In this video, we're going to talk about the 3x3 table. So the first column we're going to look at is the outcome positive, then the outcome negative. So the people who have the disease and the people who don't have the disease. On the rows side, these are what we mean by test positive is these are the people for which our diagnostic test, the diagnostic test we want to test, we are discussing right now, came up positive. So for these people, this test came up positive. For these people, this test came up negative. Remember, this whole diagram, this whole table is to evaluate our diagnostic capabilities, is to evaluate our diagnostic test. So let's go through each part of this table. First of all, if the test has come up positive and the outcome, so they also have the outcome, this is a true positive, meaning the test has also come up positive for a person that has the disease. This is a true positive. If you look at the other corner of this, the test has come up negative for someone who does not have the disease. So the test is true. This is a true negative. This is great. They're giving us the correct result. What if the test comes up negative? The test comes up negative, but the person actually has the disease. This is a false negative. Similarly, the test comes up positive for the person who does not have the disease. You don't have to remember each part of this table, but I'm just trying to explain for those who don't know the different parts of this table. So how I use the third column and third row is to keep the total of this row, of each row here and each column here. So this is how we will use this table. So this is TP plus FN. I'm not going to talk about each one of these, and let's go through each one of these when we talk about the relevant explanation. First of all, let's start with sensitivity. What is sensitivity? Let's take an example of a new test called diabetic. I have come up with a new test that is called diabetic. This test diagnoses only 52 people among 100 diabetics. So it comes up positive only for 52 people in 100 diagnosed diabetics. These are people who are diagnosed with diabetes. It came up positive only 52 times. So let's try to write this table for this test. So it came up positive. So these are all the people who have the disease. So we can write it down here. There are 100 people who have the outcome, out of which 52 people. So we can write for 100 people down here, the test came up positive for 52 people. Okay, that makes sense. The remaining people, if you minus 52 from 100, so you get 48. So these are the remaining people. These are the people for which the test came up negative, but they have the disease. They have the disease. The test, this is a false negative actually. So the sum of both of these, you can call TP, true positive 52. This is for which the test work, and the false negative, which is 48, TP plus FN. So sensitivity, you calculate the sensitivity by dividing true positive over that TP plus FN, that whole column. So how this works is 52 by 52 plus 48, or 100, 52%. So how I want you to remember sensitivity is not by remembering any columns or any rows. You need to understand the concept. Whenever someone tells you that the sensitivity for this particular diagnostic test is 85%, just know, remember this in your brain, pull this in your brain and remember it for the rest of your life. Whenever someone tells you that sensitivity of this test is 85%, that means in 100 people with the disease, the test comes up positive for only 85 people. The test comes up in 100 people with the disease. This test with 85% sensitivity comes up positive only 85 times. The rest of the 15 are false negatives. The rest of the 15 are false negative. That is how I want you to understand the concept of sensitivity for the purposes of your exam. This will help you solve all of the relevant questions. So let's take an example again. Scientists in a medicine lab have come up with a new test called diagnositension for remotely diagnosing hypertension with the help of digitally operable BP measuring apparatus. Now, I've purposefully written this question in a slightly complicated manner because this is how your exam works. They write these questions in a very difficult manner, even though the actual subject matter of which they're asking about is very simple. And so is the case with this question. I've written this question in a complicated manner, but the question itself is not complicated. The sensitivity of this apparatus is 75%. What does this mean? Close your eyes and think about this in your head. In 100 diseased people, the test comes up true positive for only 75. It misses rest of the 25 and calls them negative, which is false negative, even though these people have the disease. This is the sensitivity of this apparatus. So fill the 3 by 3 table. I'm going to take a moment to pause and you fill the 3 by 3 table if you can. Okay, so let us fill it together. So the sensitivity of this test is 75%. Now I've not given you all the details to fill this whole table. So for the details that we have, you can write 100 over here. So in 100 diseased people, just from this information, you can write 100 in a total of 100 diseased people. You have 75 people who came up to be positive, for which the test came up to be positive. These are true positives, and the remaining 25 came up to be false negative. So let me write it down for you here. So these are the people who came up to be true positive, and these are the people who came up to be false negative due to this test. This is the concept of sensitivity that you need to put in your mind. Forget about the rows, forget about the columns, forget about the people who tell you, do this equation in columns and whatever, because you're going to forget it. You need to know how to draw this table, which you're going to do at every point of this and the previous video that we talked about. We made these 2 by 2, 3 by 2 and 3 cross 3 tables at every point, so to make these calculations really easy for you. So how you think about sensitivity needs to be, out of 100 diseased people, this test comes up positive 75%, 75 times, and the rest are false negatives. So what is specificity? In the same manner, think about specificity that in 100 healthy people, a test with a specificity of 95% comes up negative 95 times, and the rest of the 5 times it says, this person is positive, this person has the disease. So false positive. I know this might sound complicated. So let's try our diabetic test again. In 100 healthy people, it comes up negative 85 times. I have not written the specificity is 85% because I want you to understand this concept. In 100 healthy people, it comes up negative 85 times. The rest of the 15 times, it comes up false positive. Let's try to write it down. Let's take a minute to pause, and I want you to write in this table. Okay, so let us do it together. So in 100 healthy people, we can write 100 over here. I must have written it down beforehand as well. So we write 100 over here. Where do we write 85? We write it over here. So this test comes up negative 85 times, and the rest of the 15 times, this is false positive. This is false positive. So that is what specificity means. In 100 healthy people, what amount of the times this test comes up to be true negative? There are 85 true negatives and only 15 false positives. If we look at the formula for specificity, you will find out that specificity formula contains the same thing. It contains, for example, if we talk about 85%, it contains 85 true negatives over true negatives plus false positive, which means 85 over 85 plus 15 if we take our previous example. So if we put in this formula for the previous table, this comes up to be exactly this. So how do we interpret specificity? We interpret specificity in a way that in 100 healthy people, how many times the test comes up negative? How many times the test comes up negative? You can go and look at the book and you can try to remember the formulas as much as you can. But for the purposes of this video and for purposes of your exam, for solving all of the questions that come up, I need you to remember these two lines. Sensitivity of 80% means the test comes up positive in diseased people. Out of 100 people, it comes up positive only 80 times. The rest of the 20 are false negatives. So TP over TP plus false negative, TP plus FN. Similarly, for specificity, in 100 healthy people, how many times the disease comes up negative? So if we have, for example, a specificity of 95%, in 100 healthy people, the test comes up negative 95 times, and the rest of the 5 times, this comes up to be false positive. So the formula for this is again true negative over true negative plus false positive. If you remember these two lines, solving any question that comes up in your exam will be like a joke to you. So let us try to put this understanding into work now with a simple example. A new diagnostic test is developed for detecting a rare genetic disorder. This test was evaluated in a clinical setting of 1,000 individuals. The prevalence of this disorder was 10%. I did not directly tell you, this is a slightly roasted question. Was 10% according to PCR and genetic analysis. The results of the test are summarized below. Out of the people that have the disorder, the test comes up positive for 70, and in healthy people, the test comes up positive in 15. So calculate the sensitivity and specificity. Let us take what we learned now in the previous few slides into action now. Okay, so let us draw the table now together and copy the numbers from the previous slide to this page. Okay, so prevalence was 10% in 1,000. What does prevalence mean? Prevalence are all the people at this point in time who have the disease in this population. So if it's a 10% in 1,000, that means 100, right? Multiply 10% with 1,000 and then you get 100. So you can write 100 here. In a population of 1,000, if 100 people have the disease, if you subtract 100 from 1,000, that means 900 people do not have the disease. These are people who are outcome negative. These are people who do not have the disease. These are people who are outcome negative. Okay, moving on. 70 diseased people turn up positive. So do you get, can you get me, just from this sentence, can you tell me the sensitivity? In 100 diseased people, the test came up positive only 70 times. That means this test has a sensitivity of 70%. But I'm not going to spoil your time. We're going to put in everything in the formula and we'll try to calculate it together. But if you understood my previous dialogue that I was talking about, then you would understand what I just talked about. But in a 70, let's just put it in here, 70, which leaves us with 30 people. So we just write 30 over here. Again, 15 healthy people turn up positive. These are false positives, meaning these people tested positive, but their outcome negative. They don't have the disease. So if we write 15 over here, if we subtract, if we subtract 15 from 900, that leaves us with 885. So these are the true negatives. These are the people who are true negatives. So let's put in things into the sensitivity formula, and sensitivity formula is true positives over true positives plus false negatives, or just all the diseased people. Basically outcome positive, all of the disease, and 100 people, the denominator will be 100. What are our true positives? These are 85. So 85 over 85 plus 15, or just put in 100. So this comes up to be 85%. TP over TP plus FN. A lot of people remember it like this. And then if you put in the formula for specificity, this is true negative over true negative plus false positive. Basically true negative over all of the healthy people. So this comes up to be 885 over 885 plus 15, which if you calculate comes up to be 98%. If you remember the way I told you, in 100 people that don't have the disease, the test turns up negative 98% of the times. 2% of the times it turns up to be false positive. A highly sensitive test rules out the disease. What does this sentence even mean? So if you're wondering this, firstly, I just want you to remember this sentence. How you remember this sentence is by the simple mnemonic of snout. Snout, a highly sensitive test, rules out the disease. So this means whenever you have a highly sensitive test and it comes up negative, that means you're almost certain that this person does not have the disease. Why? Because if you remember, in 100 diseased people, if your test has the sensitivity of, let's say, 100%, that means it always comes up to be true positive. There are no false negatives. You never have a false negative. So whenever this test tells you that this test is negative, that means you're almost certain that this person does not have the disease, or this test would have turned up to be positive. Let's take an example. Mercurius makes a highly sensitive test with almost 99% value of sensitivity. Meaning in 100 diseased people, it gives only one false negative, only one false negative. All of the other ones are true negatives, Therefore, a highly sensitive test, when it comes up negative, is great at ruling out the disease. Just remember snout. If you have to remember snout, and snout will tell you that a highly sensitive test, when it comes up negative, essentially rules out the disease, because it has very, very few false negatives, And similarly, a highly specific test, when it comes up positive, rules in the disease. How does that work? First, remember the mnemonic of spin. Spin, a highly specific test, when comes up positive, rules in the disease. Example, so Dr. McFluffy makes a new test with 99% specificity, 99.9% specificity for HIV. That means in 100 healthy people, it gives only one. Sorry, this is wrong. This should be 0.1. It gives only 0.1 false positive. What does this mean? This means that this test gives very, very few false positives. So whenever you have a positive, it's a true positive. Therefore, a highly specific test is great when it comes up positive for ruling in the disease. You mean this test almost never gives false positive. That means this test is great at telling you this person almost specifically has the disease. Now, let us talk about a concept called predictive values. I want you to remember the formulas for predictive values and use the trick that I use. So just remember the formula for positive predictive value, and you will remember the formula for negative predictive value by itself, just by remembering this formula. How does this work? So the positive predictive value, just remember the two P's in this name, positive predictive. And then the formula for this also has two P's, true positives plus false positive. Both of these are two P's in the denominator. Similarly, so true positive over true positive plus false positive. Positive predictive value has two P's, its denominator also has two P's. If you just remember this formula, then negative predictive value follows the same principle. Negative predictive value is Tn true negative over true negative plus false negative. It's the same principle being repeated again. You don't have to remember the theory from this. If you remember how to make this 3 cross 3 table, this is when the 3 cross 3 table becomes relevant. 3 cross 3 table. So TP plus FP, this value is great for letting you calculate the positive predictive value. This value is great for letting you calculate the negative predictive value. This value is great for letting you calculate specificity, and this value is great for letting you calculate the sensitivity value. That's why I talk about the 3 cross 3 table whenever you have a diagnostic test calculation. You need to make this 3 cross 3 table, and that's why for every calculation in this video, try to make the 3 cross 3 table yourself. Positive predictive value is true positive over true positive plus false positive. Like I just said, two P's in the denominator, true positive plus false positive. Once you get two P's in the denominator, for negative predictive value, remember two N's in the denominator again, true negative plus false negative. And of course, in the numerator, it's going to be true negative. Simple as that. If you just remember that, let's do an example to understand both of these. A new diagnostic test is developed to detect tuberculosis in a high prevalence community. This is not for no reason, and I'm going to explain this in a bit. In a high prevalence community clinic, the prevalence of TB in this population is 25%. That's a lot. This TB has the following characteristics. This test has the following characteristics. Sensitivity of 95%, specificity of 80%. Let's explain this. In 100 diseased people, this test gives 95 true positive and 5 false negatives. Similarly, a specificity of 80%, meaning in 100 healthy people, this gives 80 true negatives and 20 false positives. This test is conducted in a population of 1,000 individuals. Okay. Out of the healthy people, 110 turn up positive and the disease 180 turn up positive. Let us copy all of the numbers to the next page and try to make a 3x3 table ourselves. Now I want you to use these numbers to make this 3x3 table yourself. Okay, let us make this table now again with each other. So we know that 25% of 1,000 comes up to be 250, right? So this comes up to be 250. 250 in 1,000, that means you can write 750 over here. So this is 750. These are people that don't have the disease. Prevalence, as I said earlier, prevalence at one point in time is all of the people who have the disease in a population. So 180 diseased people turn up positive. So 180 diseased people turn up positive. You can write it here, and that leaves us with 70 people. So you can write 70 over here. 110 healthy people turn up positive. These are false positive. So you can write 110 healthy people over here, and if you minus 110 from 750, that leaves you with 640. Now we want to calculate, if we want to calculate the positive predictive value and the negative predictive value, we should write the values over here as well, which is 290 and 710. Let us put in the value for positive predictive value for this particular question. So if we write here 180 over 180 plus 110, TP over TP plus FP, as I said, 2 P's and 2 P's in the denominator. And this comes up to be 62 or 62%. This is 62% positive predictive value. Similarly, for negative predictive value, you have 2 n's in the denominator. So true negative over true negative plus false negative. Just use this. True negative over true negative plus false negative. 640 plus 70 comes up to be, I think, 710. So 640 over 70 plus 640 comes up to be around 90%. So this is the negative predictive value of this test. Now I have a question for you. Can the prevalence of a disease affect the sensitivity or specificity of a test? The answer to this question is no. These values, the sensitivity and specificity of the test, are inherent to the diagnostic test, the diagnostic capability of the test itself. The prevalence of the disease in the population characteristics do not matter. They do not affect the sensitivity and specificity of a test. So the next time when your attending says in the ward that the sensitivity of this test in this population is not great, tell him. Actually, don't tell him, but you can think in your mind, maybe this is not right, because the sensitivity of a test, the specificity of a test is a permanent thing that is associated with the test itself. It does not vary with each population. For example, a TB culture is always sensitive and specific, regardless if it's India or the United States of America. These can be population with very different prevalence of tuberculosis. So what does the prevalence of the disease affect? What value of the test it affects? Can the prevalence of the disease affect the predictive values of the test? The positive predictive value and the negative predictive value? Yes. This is what the prevalence of the disease affects. So a positive TB test in India is more likely to be true positive than in USA, because the positive predictive value of a test is affected by the prevalence of the disease in the population. You need to remember this for your exam. The prevalence of the disease in the population can affect the predictive values in a test, but not the sensitivity or the specificity. So remember the positive predictive value is directly proportional to the prevalence of the disease. What does this mean? That means if you have a population that has a very high, that has a very prevalent disease, for example, in India, in Pakistan, there is a TB or tuberculosis is prevalent. So in these countries, the positive predictive value of TB tests is very, very high. So what is low? The negative predictive value of these tests in these countries is low, because a positive test is very likely to be true positive and a negative test is more likely to be even false negative. It's more likely to be false negative. So remember, the positive predictive value of the test directly varies with the prevalence of the disease. So as the prevalence of the disease increases, as the number of diseased people increase, the positive predictive value of our test increase, but the negative predictive value goes down. Now let us talk about likelihood ratios. For the purposes of your exam, I just want you to remember these two things about likelihood ratios. First, they're formulas which are extremely simple formulas. So positive likelihood ratio works TP over FP. Just keep TP over, because true positives, meaning truth prevails. Truth prevails. If you're a truly positive person, just know that truth will prevail. But for negative likelihood ratio, if you're a very negative person, then you might lie. So just remember that false negative for negative likelihood ratio, so it's Fn over Tn instead of the other way around. So for positive, if you're a truly positive person, just know the truth prevails and you have Tp over Fp. And in this case, if you're a truly negative person, for negative likelihood ratio, it is highly likely that Fn will prevail instead of true negative. And this, now I want you to remember these two formulas. This is not a very highly tested or a very high yield topic, but I've added this here for the sake of completeness. Now I want you to remember two things about this page. First, these formulas, and second, this part. A test is considered very useful if it has a positive likelihood ratio of greater than 10 and a negative likelihood ratio of less than 0.1. These are basically used by clinicians to help them with choosing a test. So there are two things in this slide that I want you to remember. First, their formula, in positive likelihood ratio, truth prevails, meaning TP over FP. And in negative likelihood ratio, if you're a very negative person, just know that false negative will come up and true negative will go down. So that will become Fn over Tn. And a test is considered useful if it has a positive likelihood ratio of greater than 10 and a negative likelihood ratio of greater than 0.1, because you want this numerator to be small. You want these false negatives to be very, very small. You want this whole thing to be smaller than 0.1. So there are two things you only need to remember: the formulas and this whole part. So let us now summarize this whole mammoth of a video within a very few slides. First of all, I need you to make the 3x3 table, the outcome positive, negative, and then the total, and then the test positive, negative, and then total. The 3x3 table. If you want to make a diagnostic test calculation, make the 3x3 table. Sensitivity. What is sensitivity? Sensitivity is in all diseased population. 85% means 85 true positives and the rest are false negatives. And that is exactly what the formula of sensitivity is as well. TP over TP plus Fn, false negative. These are all of the people who have the disease. And when we talk about specificity, we have the same thing but in healthy people. So 80% means 80 true negatives and the rest are false positives. So this is Tn over Tn plus Fp. Sensitivity and specificity do not depend on prevalence. These are inherent values of the test itself. They do not change with the amount of diseased people in one particular population. A test is not more sensitive just because it's being practiced in a different place. Predictive values are in total negative or total positives, meaning when we talk about positive predictive values, it has those two P's. So therefore its denominator will have TP plus FP and numerator will of course be true positives. And Negative predictive value will then again have Tn over Tn plus Fn, those two n's, remember that. Predictive values depend on the prevalence. They do vary with the prevalence of the disease in the population. For likelihood ratios, I want you to remember those two things. If it's a positive likelihood ratio, truth prevails. It's going to be Tp over Fp. And for a negative person, negative likelihood ratio is going to be Fn over Tn. So false negative is due to false negative being in the numerator of negative likelihood ratio. You want this value to be extremely small, and you want the positive likelihood ratio to be high, high, high. That's what makes the test very useful. In the end, thank you so much for watching this video, and you are doing amazing. Stay tuned. Subscribe.